Mathematics-02 of Engineering and Technology.
Equations and the method of general solution as a particular integral specifically for sine or cos function. Remember, in our previous video, we considered the first special function as exponential function. Today, our focus is on sine or cos functions. So let us start this first part of this discussion, which is how to consider second order derivative, how to consider auxiliary equation, and then how to go for particular integral. So for simplicity, I am considering second order differential equation y double dash plus c1y dash plus c2y equals to r of x. Again, over here y is dependent variable on x, dash and double dash indicates first and second order derivative respectively. C1 and C2 are arbitrary constants, and Rx on the right hand side over here it indicates a random function of variable x. If we define differential operator d by dx as capital D and nth order derivative by power n, then we can find the operator form of this equation as d square y plus c1 d by plus c2y equal to rx, which can be converted further into d square plus c1d plus c2 times y equals to r of x. And later on, we can consider this into the differential form as f of dy equal to r of x. This is our first step in all solutions of higher order differential equations. Now let us move further for particular integral. For particular integral, there are four techniques, out of which we are focusing on these three in this video series. Right now we are at this direct method or for the special functions, in which we are focusing on sine or cos functions after discussing for exponential function. Later on, we'll also focus on these two methods, method of undetermined coefficients and method of variation of parameters. So let us start our method for special functions, in particular for sine or cos. So once we have this operator form f of dy equal to r of x, we can take a particular value of y as yp by transforming this f of d as 1 upon f of d with rx. Then it depends on the value of this function. As I told you, it can be any standard function, and in this talk we'll consider it as sine or cos. It can be one of the following forms. It can be exponential function, which is already discussed in my previous video. It can be sine or cos, which I am going to discuss in this talk. It can be polynomial. It can be exponential into random function. It can be power function, x raised to any power of x into rx. All these are going to be discussed in my upcoming videos. So let us focus on trigonometric functions, in particular for sine and cos. Okay, so suppose this function rx on the right hand side of yp is sine of x plus b. Then remember one thing, as in case of exponential function, we are focusing on 1 upon f of d. In case of sine or cos, we are focusing on d square into the equation. You cannot change the values of d, you can only change the value of d square, or you can say the even powers of d. So if I have 1 upon f of d square sine of x plus b, then I can replace this d square by minus of a square, with condition that this f of minus of a square is not equal to 0. If it is equal to 0, then we have to follow the same technique. multiply outside by x, take derivative of this with respect to d square or with respect to d, and then replace everywhere with d square as minus a square. Let me repeat once again. 1 upon f of d square is replaced by minus of a square. Condition is that this f of minus of a square should be non-zero. If it is 0, then take derivative with respect to capital D, multiply outside by x, then again replace d square by minus of a square. You can repeat this process until this denominator is non-zero. Let us see some examples. So, suppose I want to find solution for this. The question is solve the given differential equation y double dash minus 5y dash plus 4y equals to sin x. In this case, I will take f of dy equal to rx as d square minus 5d plus 4 times y equals to sin. This is nothing but the differential form of given differential equation. Now, let us consider auxiliary equation for complementary function. So, I am taking f of d equals to 0. Factorizing it will give you two roots, 4 and 1. So, it is case of real and distinct. So, I am taking c1 e raised to 4x plus c2 e raised to x. Now, coming to the second part, which is particular integral, I am taking yt as 1 upon f of t of rx means 1 upon d square minus 5d plus 4 of sin x. You can see over here the value of a, which is coefficient of x in sine of x, is 1. So I can replace d square with minus of a square, and that means d square is minus of 1 square, and that means d square is minus 1. So I will replace this value of d with minus 1. Once I replace value of d square with minus of 1, it will be 3 minus 5. Now remember here I cannot change this value of d, as we know that in case of sine and cos you can only change the even powers of capital D. So it will give you 1 upon 3 minus 5d. Now how to get rid of this odd power of d? So for that we are multiplying and dividing by the conjugate of this 3 minus 5d, which is nothing but 3 plus 5. So I am taking in numerator 3 plus 5, in denominator I am taking 3 plus 5, so it will give you 9 minus 25 d square in denominator. Again, replace d square with minus of 1. So it gives you 1 upon 9 minus 25 into minus 1, 3 plus 5d as it is in numerator. So this denominator is 9 plus 25, which is nothing but 1 upon 34. And then I am multiplying the sine function with 3 and sine function with 5 of d. So it gives me 3 times sine x plus 5 times d sine x. Now what is meaning of d? D simply means d by dx. So I am taking derivative of sine function with respect to x of order 1 because it is d raised to 1. So it gives me 3 sine x plus 5 times cos x. You should pause and ponder at this stage and you can check what is happening in this solution. And so the value of particular integral is 1 upon 34, 3 sin x plus 5 cos x. Finally, by combining this yc and yp, my general solution would be c1 e raised to x plus c2 e raised to 4x plus 1 by 34, 3 sin x plus 5 cos x. This is how you can find the general solution in case of particular integral where it is depending on sine and cos. Let us go through second example. Now equation to solve is y double dash plus y equals to sin x. So operator form is d square plus 1y equals to sin x. Considering complementary function by taking auxiliary equation f of d equals to 0 is d square plus 1 equal to 0. So the roots are m1 m2 given by 0 plus or minus I. So clearly we can see that alpha over here is 0, which is nothing but the real part. Beta over here is 1, which is nothing but the imaginary part. And so we will get complex pair of roots. And for that, complementary function is c1 cos x plus c2 sin x. It is actually e raised to alpha x in bracket c1 cos beta x plus c2 sin beta x, with alpha equals to 0, beta equals to 1. Let us see what is happening to the particular integral. So here yt is 1 upon f of t rx, which is 1 upon b square plus 1 into sin x. Now here, if you replace this d square with minus of a square, the value of a over here is 1. So value of d square as minus of a square will be minus 1. And in that case, what will happen? If you replace this d square with minus 1, denominator will become 0. So we cannot replace directly d square by minus of a square. And in that case, the process is you multiply outside with x and take derivative of this denominator with respect to d. So it will give you 1 upon 2d. Now, if you have d in multiplication, then it gives you derivative. But if you have d in denominator, means if it is 1 upon d, then it is the reciprocal process of derivative, which is nothing but integration. So if I have 1 upon d, it indicates the integration of this function with under this operator 1 upon d. So I am taking 2 outside, so it is x by 2, and then integrating sin x, it gives me x by 2 of minus of cos x. Now let us consider this as yt. So it is minus x into cos x by 2. You should again pause at this stage. You can go through this solution step by step, try to understand it, that in which case I am replacing directly d square with minus 1, minus of a square, and in which case I am taking derivative. And remember one thing, you cannot change value of d, you can change only value of d square. And so the general solution would be c1 cos x plus c2 sin x minus x into cos x by 2. I hope this part is clear now, that how to figure out particular integral in case of sin and cos. Remember, this technique is only and only useful for sin and cos. You cannot use it for another trigonometric functions like tan, sec, cot, cosec. For that, we have another methods. Thank you.
LJ Institute of Engineering and